This is episode number 439 with Deblina Bhattacharjee, artificial intelligence researcher and deep learning engineer. Deblina, welcome to the program. We're so excited to have you back. It's been 4 years. Deblina was a guest on the Super Data Science podcast in 2017 when she was pursuing a master's in South Korea. We can't wait to hear about all of the exciting updates that have happened since then. I know from already talking to you before we started recording that you are an extremely interesting person with so many diverse interests. The research that you're doing, the commercial projects you've had in the data science sphere are all so exciting. I can't wait for our audience to hear about it as well. Welcome to the show.
Thanks a lot, Sean, for having me over here. It's equally exciting for me to come back to Super Data Science podcast after 4 years. Back then, I was just a student. I'm still a student. I think I forever will be a student. I have learned much more than what I've had known whilst doing my master's in 2017 when, for the first time, Kirill interviewed me. But it's really exciting to be back on this platform again.
Nice. So when in 2017 you were doing a master's, what was it? What was the research focus?
So I graduated in 2017. When I started my master's, it was based on evolutionary computation. So I was working to simulate or model mathematically the intelligence mechanism of biological plants, which is different. Yeah, which is different.
The intelligence mechanism of biological plants?
Yeah.
What does that mean?
Which is quite different, actually. So I had to sit in meetings with different biologists and even go through the biochemistry and how signals are transducted amongst the different plants, how they communicate with each other, what kind of sequencing is done when they have some chemicals being transported, and what happens, like the inner mechanisms. So I studied that and tried to model it mathematically. I don't think I was so successful, but there were quite so many obstacles, which is always there, ever so slightly in any research. Anyhow, I did model, come up with something, and finally, I presented, I think, my first paper at one of the student research competition in ACM in Italy back in 2016. And there, the judges happened to ask me that what are the possible implications of the research and where are you going to apply it? So I did not have an answer that time, so I couldn't really finish the competition at the top. But then later, I had more discussions with my advisors and the other people on the team. And frankly enough, I really had no clue. And then there was this new project where I had to identify white blood cells from medical images. So I was like, why not turn the modeling from the evolutionary computational perspective into a search optimization solution to solve such problems. And so I did that. And finally, that was used to solve some medical imaging problems.
So let me interrupt you I got one quick question and then maybe a longer question. So the quick question is, just for our listeners' sake, what is the ACM competition that you were at? What does ACM stand for?
So it's Applied Computer Machinery, I think, ACM. Yeah. And it's one of the top bodies of research in computer science, yeah.
Definitely. This episode is brought to you by Super Data Science, our online membership platform for learning data science at any level. If your New Year's resolution is to skyrocket your data science career, then we have something super special prepared for you today. Until the end of January 31st, you can lock in year-long access to the Super Data Science platform at a deep discount. You save 40% on the annual plan and pay only $166 instead of the usual $276. Our streamlined user interface will enable you to move easily between learning materials and become a top data scientist, business intelligence analyst, or machine learning engineer. Inside the Super Data Science platform, for a whole year, you'll have unlimited access to all of our 50+ courses, which together provide over 300 hours of content. And finally, you will be part of a community of talented, inspired, and driven data scientists who are keen to learn together and grow their careers together. So, don't hold off. Visit superdatascience.com and save 40% on your annual membership. Available only until the end of January. Once again, the website is superdatascience.com. And now, let's get back to this riveting episode.
Yeah.
And then, so let me try to summarize what you just said. Was that so you were doing this research, you weren't really aware of the practical implications. So you're kind of in a way, I mean, not basic math, because you weren't like, studying topology or something, but you were coming up with mathematical models to try to simulate the intellectual behavior of plants.
Exactly.
And you weren't sure what usefulness that would have. But then for a separate project, you were trying to identify white blood cells in images, and you were able to use some of that math to do that work. Wow.
Exactly. Yeah. So when it started, I really did not have an idea, as I said, but my advisor said that plants have this inherent intelligence, which if you see a plant growing, well, it depends on which species of plant growing, but inherently they follow the Fibonacci series of growth when they branch out. Even the root has some way to find the water gradient within the soil. So they have this kind of, which comes from evolution, because they have been surviving since eons. So to understand how to, optimize the search grid and basically force the agent to locate certain things which are not, the scarce resources. So that's what the plan does. So if you see, inherently it has kind of intelligence going on. So we sort of, why not model it? There were, as I said, I stumbled upon how to start it. So there was a lot of calculus. There was all kinds of graph theory. There was, of course, geometric based. There was topology too involved to understand. Yeah. So finally, I came up with an objective-based function and an algorithm which can work. Also, there was some reinforcement signal used because, of course, it's like an agent searching through an unknown world to find its goal. So it was something like that. And ultimately, I used that into this particular leukocyte or white blood cell detections, because the thing is, it aids doctors in diagnosis much faster if it's automated, because manually finding them is expensive and time consuming, and also subjected to inter and intra observer variability, depending on who is examining it. Although the people doing it are very well versed and very skilled at it. But detecting white blood cells from medical images from the blood samples are very, very difficult. So I thought maybe I can use it. So I had to change it to basically a search optimization problem and apply this particular algorithm to find the solutions to them. And it was the accuracy of it was pretty high, and the publication is still there. I think it was AAAI that I published the paper in. So back in 2017, 17, So that was it.
That sounds amazing. And you've been doing computer vision research since, right?
Yeah, exactly.
So if I remember correctly, it was a relatively brief stint, a stint for a couple of years at Samsung in South Korea, which is where you did your master's. And then you started a PhD, which you're doing now. So maybe tell us a bit about, I mean, without going into intellectual property at Samsung or something, but let us know a little bit about the kind of computer vision research that you were doing at Samsung. Probably not detecting white blood cells, though maybe. And then tell us about what you're doing right now in your PhD.
Okay. It's pretty interesting because I always had this diverse focus of how to apply a given set of solutions, maybe differently to existing problems, and either that or to attack as many fields, if not a single field, and not deep dive into it. So my area of research, a focus of research, has always been across multiple fields. So when I finally graduated in 2017 from Kyungkook National University in South Korea, I got this job at Samsung Intelligent Media Research Center in another city in South Korea. And there, because South Korea was at that time hit by consecutive earthquakes, so there was this project by the government over there where they told the researchers who was being hired to formulate an architecture, model an architecture where you can use computer vision in order to solve the early earthquake detection problem. So the moment that the secondary wave or the S wave hits a particular building, the building starts shaking, and then a person understands the severity of the earthquake. But what we do not understand is when the P wave hits, because it's relatively, you cannot actually decipher when it hits the building or anything, right?
So what's the P wave?
The primary wave. P wave is the primary wave. The amplitude is
the most destructive part of the earthquake, I guess.
The most destructive part is actually the secondary wave, which is much larger in amplitude, and the way how it travels within the Earth is also different. The primary wave, the amplitude is much lesser because it's the first when it just starts. So my work was, and actually MIT CSAIL was also doing the same work, and my inspiration for the work, because I had to use computer vision for this, was the publications by MIT CSAIL. I think it was Abe Davis, his work on visual magnification. So you basically take the amplitude and you magnify the phase of how the waves are traveling into your algorithm. And this is all captured by simple conventional cameras, even your mobile phone can do now. So you just capture the fluctuations in the normal vibrations of the building, and you record that, and you use that particular thing and monitor the amplitude and the phase, but you have to magnify the phase because those vibrations are not commonly visible to the human eye, but it might be, of course, visible to the computer vision algorithm, which you have trained it on. So that was the overall thing that we were working on. So that was
this whole time I forgot that we were even talking about computer vision. I was kind of imagining like I don't know, like I was thinking of like time series analysis, maybe like detecting vibrations. But you're using computer vision to detect changes in the movement of a building,
exactly.
And that can be used to predict when an earthquake is going to hit. Wow.
Yeah.
That is super cool.
Yeah, it was very interesting for me to work on too. So once I finished that project, there was a personal stuff for which I had to quit and come back to India, where I'm originally from. So I went back to India, and then within a month, I received this offer letter from EPFL at Switzerland for where I got directly hired into a lab. So
nice. EPFL is it's a top Swiss university.
Yeah, exactly.
I know it. It's in Lausanne, right?
It's in Lausanne. So under the advice of my so I'm jointly in two labs. One is the image and visual representation lab, and the other one is the computer vision lab at EPFL. So I'm working on a particular large-scale computer vision project right now, and it's also the crux of my doctoral dissertation. So it would be. So I was very much interested because it's European arts. What better place to study arts than in Europe? So I got this project where I had to bridge the gap between arts, digital humanities, and computer vision.
So when you say landscapes, you're talking about fine art. You're talking about painted landscapes.
Yes, I'm talking about that. And not only landscapes, even historical periodicals from the yesteryear, starting from the end of the 19th century till the beginning of the century. Comics also, magazines. The artist had, from that time, there are so many comics, European comics. They have different artistic styles. So I'm working...
Like Tintin?
Oh, yeah, for sure.
Really?
Yeah. they call tan tan over here because it's a French-speaking
Yeah,
part of
right, right,
Switzerland.
right. Of
Yeah,
course.
so tan tan. So to reconfigure all those things into digital platform in order to, maybe form an augmented reality, animated, and to basically do scene understanding out of all these things. So that's the broad
What?
focus of the project we are working on.
Wait, wait, wait. The idea of the project is to use computer vision to
Uh-huh.
take landscapes from any source. It could be fine arts, it could be comics, it could be from magazines,
Mhm.
and turn that into like an immersive experience.
Yeah, the end goal would be to turn it into an immersive experience. But right now, because it's still at its very inception, the project, and we are taking baby steps. So we are
Oh, yeah.
just working with saliency and depth estimation, style transfer to get it going. So ultimately, using all these different methods, we'll try to understand the scene and retarget the images from these particular comics or periodicals and magazines of the yesteryear to the digital platforms. It might be a tablet, a television, or even your mobile phone.
And
And
maybe
then
need VR goggles.
we will do
Oh, yeah.
animation. Yeah. So VR goggles for sure later. But that depends on the success of the
Wow.
previous steps. So
Wow. So in a few years, maybe, or maybe a little longer, we'll see what
hmm
happens.
yeah, sure.
But theoretically, we could have kids who pick up a Tintin
hmm
comic book, and then they can also put on VR goggles and go into the scene that the hero of the comic book is in.
Oh, for sure. It's a very ambitious project, but I guess it would be something really interesting because
Yeah.
I think it forms part of entertainment, a new avenue of entertainment which was not so explored, and we're trying to explore that. So let's see how it takes where it takes that. Yeah,
That's amazing. I mean,
yeah.
so I started off this podcast by saying there's so many interesting things about you, and I can't wait to get to them. But we haven't even gotten to any of those things yet. Everything that you've said is completely new to me. Oh my goodness. All right. So that's one of the labs you work in on your PhD. What's the second lab that you work in?
So so image and visual representation lab and computer vision lab. These two labs have hired me jointly in order to work in this project.
Oh,
So
I see. I
yeah,
see.
yeah.
I
So
see.
I'm just a joint member of these two labs. Yeah.
I understand. Okay. Well, that was an amazing intro to what you do professionally, but I also know you have a very interesting hobby that I would love everyone to know about. And I'm hopeful that we can somehow find a link so that people can enjoy this from home. But I discovered while we were chatting before recording that you are a drummer in progressive rock bands.
Mhm.
So tell us about that and tell us what kinds of artists you love to cover. There are some of my favorite bands. It's my favorite genre of music, and so I'm so excited that this is something that you do.
So prog rock, I got into it when I was in high school. No, rather I would say middle school, because there was this drummer who had to change schools, and so there was no replacement. So that was the first day. So the music teacher was like, "Who is ready to drum?" And I think I was the only girl in that particular team. So I was like, "Why not? Let's give it a try." So it didn't work out for the first 2 hours that I was trying to pick up the beat and play. Then I just took a break and I was really trying hard. And somehow I don't know how I could sing the beats. And I got selected during the audition. But I'm thankful that my music teacher gave me the extra time, which was required to practice. Otherwise, I wouldn't have been a drummer. And I'm nowhere near a proper drummer or a professional drummer. I just do it out of love for drumming. So I
I like that you say that, but prog rock has some of the most complex drum rhythms possible. So when you say something like that, I have this feeling that you're an amazing drummer, but it's just that you're like, well, I'm not actually a professional prog rock drummer.
I mean, prog rock has such difficult beats and the synchronization and the way it changes. It's really difficult to actually follow it through. So I try to improv sometimes, but it really isn't improv. It's like literally escaping the tough parts of it and replacing it with something that you can do.
Right.
So yeah, so from high school, actually, my friends of the band that I was in, we used to play a lot of classics, and then it was more of pop classics, alternatives, and like Beatles, ABBA. And then finally we were like, wait, prog rock is so fun, like lyrics wise also. And it was really an escape route to me. So I delved into it throughout my undergrad school also. I really liked it, liked listening to it. My favorite bands, I always liked Dream Theater. I really like the way how it progresses. The Systematic Chaos is one of my favorite albums. There are so many other albums, but it would just take a lot of time, and that's another podcast I think I can do.
Sure, yeah, we don't need to go into that too long. But is Dream Theater? That's the one with Steve Vai as the guitarist. Is that right?
Petrucci.
Petrucci. Oh man, just embarrassed myself.
Yes, no. And Pink Floyd too. So we cover a lot of those things. Beautiful, beautiful songs, because all based on the guitarist that we have. We have a fantastic guitarist. So yeah, and sometimes we go to Genesis. Love that band too.
Love Genesis.
Yeah, Riverside is another. I don't. There's a friend who got me introduced to this band, Riverside. That's equally fun. I love their album. And yeah, there's so many. I really can go on and on and on about this particular thing. Talking.
Yeah. It's like, speaking of complexity and originality in prog rock drumming, Phil Collins was a drummer in Genesis for a long time, right before going out on his own, and he has really incredible drumming originality. I'm in my head. I'm like, I'm planning on like, I'm imagining it in my head, but I know that if I try to make it come out of my mouth, it's going to just be terrible, and everyone's going to switch off the podcast.
Oh no!
But I have in my head, I have the like really famous Phil Collins song. I'm not going to start singing it. But amazing. So I think what you do is absolutely so fascinating, to be involved in so many different kinds of mathematical modeling today in computer vision. So what's a day like in your role doing your computer vision PhD in Lausanne?
It's heavily focused on research. So I would say 60% is research and 40% experimentation and implementation of the ideas that I come up with. So the day usually starts with going to the lab, and now because of COVID, it's work from home in my office over here. So basically, you get up, you start with a particular set of papers that you might have, like state of the art, that you read through, and always try to keep up to yourself up to the latest trends in that particular field that you're working in, because that's very important. Things which were prevalent 2 years back or even last year have already become obsolete and have been beaten by the latest state of the art. So that's important. And then sketching out a new method or your proposed method that you want to actually implement. So that goes into the research time. So it takes 60% of my work week. And then the remaining 40% is coding, which I do using Python and PyTorch. And sometimes MATLAB is required. And when you have some MAT files, some H file, it depends how you're saving some file format. So you just need to port it from one language to the other. And of course, mathematics is very important. I start with I cannot stress how important it is. Like linear algebra, for at least when you're working with machine learning. So linear algebra, calculus, you have to know statistics well, a bit of probability. Theory of probability is important. And what else do I work with? Visualization. You should know a good way, a tool to visualize your results, because you have to communicate it with your team at the end of the day. So if you do not know how to, you might have fantastic set of results, but if you do not know how to communicate with the rest of your team, then I don't think it gets lost in the translation, I feel. So that is how I go through. And also inspecting my failure. Whenever, like most so often it happens, like I come up with an idea and I just lose track, like why it was supposed to work. Theoretically, I might have proved it, but then I also try to disprove it, but when I work on the system, it just doesn't make sense anymore based on the domain that we are working on. So I just try to inspect those failure cases, because when that happens, you know of one more way of how not to tackle the problem. So I spent a lot of time into those inspections as well. Yeah.
I am so happy that so this is going to be a bit of a shameless plug,
Okay.
but you're talking about the importance of linear algebra, calculus, probability, statistics, and then also data visualization. But
Yeah.
so I know that Super Data Science does have great data visualization courses that you can get through superdatascience.com or Udemy. But those other topics, linear algebra, calculus, probability, and statistics, I've been working. So through 2020, I was developing my machine learning foundations content, which covers exactly those topics, because I also appreciate how critical those underlying subjects are to being able to do data science at a really high level. And so, did you know about this? Is it? It's a complete coincidence that you're bringing this up, I imagine.
I did not know what the course.
Yeah. Okay. Great. So I have this course called the Machine Learning Foundations course,
Okay.
and so like if you look at, so there's like in GitHub Machine Learning Foundations, you'll get my Machine Learning Foundations course. So all of the code, I've already created it for all of these subjects.
That's fantastic.
And we have live in Udemy today. We have almost all of the linear algebra content live in Udemy, in a course where Super Data Science is my partner on getting this stuff published in Udemy. And so, being able to leverage the expertise that Super Data Science has in creating the most popular machine learning courses of all time in Udemy. But anyway, so it was just basically a shameless plug, but we're speaking the same language here.
I think it's going to benefit all our listeners. So for sure. Yeah.
Nice. All right. So, so you end up working in Python, you end up working in MATLAB, PyTorch library you mentioned. Are there any other key libraries that you work with a lot in Python? So maybe for data visualization, Seaborn, maybe something like that?
For the project that I'm right now working with, it's basically Matplotlib and a lot of NumPy, scikit-learn. So that's basically that I'm working with. Yeah, classics. Sometimes Wisdom to visualize what's happening with them. Yeah.
I haven't heard of that. Wisdom, just like WISDOM.
No, it's I think ISDOM, if I'm not mistaken. Yeah.
Got it.
But I might be wrong. I rarely check the spelling when I'm coding because the editor takes care of that. So
right. Well, we'll find it and we'll make sure that it's in the show notes so that listeners can click through and find that. Awesome. And then, so we know that a big chunk of your day is spent reading machine learning papers, staying up to date on the latest state of the art. Have you come across, we're recording right in the beginning of January 2021, and this really exciting, I've been completely blown away by this model that was released this week, which is called DALL-E by OpenAI. Have you come across this?
I saw that. It was great, but I did not really read through the paper as of now because I couldn't find time yet. But yeah, I saw that in one of the news, the articles that I follow. So that was great. Yeah.
Yeah. It relies on GPT-3, which isn't available to the public. So this model isn't available to the public either. But this model takes text, free-form text that you write, and converts it into an image. And it is mind-blowing. If you go to the DALL-E blog post, so it's pronounced like Salvador Dali, but it's spelt like the Disney Pixar movie WALL-E, about the AI robot. So it's DALL-E in all caps. And so viewers, if they Google OpenAI DALL-E, that'll take you right to the blog post. And in the blog post, you can, I don't know if you played around with this, Deblina, you can change inputs into the model. So you can't type anything you want, but they give you a broad range of possible inputs. Like, So like for example, I created illustrations of an avocado with a mustache skating on ice. and it automatically creates for you like 25 of them, and you see 25 completely different avocados with mustaches skating on
Wow,
ice.
that's so cool.
A bok choy with headphones sipping a latte, a cucumber in a leather jacket looking in the mirror. And
Really cool.
one of my favorites was a sleepy pepperoni pizza slice,
Oh,
which it did an amazing job.
that's
Uh,
classic.
it creates a pizza slice, but the
Yeah,
pizza slice looks sleepy. So
sleepy.
yeah, it's amazing. It has like a face on it. I don't know. Yeah. So it's mind blowing to me how quickly things are changing. And I went off on a bit of a tangent just so I could talk about Dolly, but um,
Oh, that's really interesting. After this podcast, I'm going to check that out.
awesome. I think we've already kind of touched on this, uh, by talking about, Python,
Mhm.
MATLAB, linear algebra, probability calculus, statistics, data visualization. Are there any other key skills that you think our listeners should have to be a great data scientist, either as an academic like yourself, or maybe in industry?
Um, I would say so. It depends really. Like if you're talking about data science or if you're talking about a decision scientist. Because if you're a decision scientist, and if you're at a say the mid management level of a project in an industry, then the domain knowledge is very much important. But if you're just a data scientist at the junior level, the domain knowledge is not that important. Rather, the implementation side of it, the mathematical side of it, is more important. For the data scientist, I would like to say all the above things that I said before, which was linear algebra, calculus, stats, probability, particular visualization tool, communication, how to present maybe a PowerPoint presentation or a keynotes or whatever you like it. And of course, like coding, a good grip on a coding language and a deep learning framework. It's kind of important, be it for any job across industry or even for academia. But when it comes to domain knowledge, I wouldn't say that the stress is so much on the data scientist, because the decision scientist knows a bit more about the domain and um, tries to educate the data scientist about the type of data that he has to work that they have to work on. I think an intermediate level of domain knowledge should be important for a decision scientist, but and a beginner level of domain knowledge is okay for a data scientist. That's the only difference. Also, I would say knowing Git, like the bash commands, it really helps, and it has so many shortcuts. Even during programming implementation, really helps. And it depends from industry to industry, because I remember the first job that I had, they wanted me to know C with Python and sometimes Python. So there are a lot of different, that it depends on which company you're working in, and on what project you're working on. So I would say it really is a broad spectrum question, but ultimately you should like try to target these areas. Yeah.
That was such a perfect answer. You articulated that beautifully. Um,
Thank you.
the only thing that I want to circle back on and make sure I'm getting right is, what were these key differences between a decision scientist and a data scientist? So the decision scientist was a bit more senior than a data scientist, who you would consider like more entry level role.
Normally, I would say yes, at least in the industry that I was in, and even in the projects that I've worked on, I have seen the decision scientists to be at a senior level, who know the project much more, depending upon the domain knowledge that they have, and they know the data much more than the researcher or the data scientist who is going to work.
Got it.
So they are the people who explain the data and even the project. They break down basically the complex end goal of the project, the end problem, into sub problems, easier problems, so that the data scientists can tackle it. And whilst doing that, they also explain the data that they will be working with. So I think that's the difference.
Amazing. That's so helpful, Deblina. I can only imagine that that's really helpful guidance for our listeners. Another question related to this is, what do you think is coming in the coming years? So what should a data scientist be doing to prepare for the future? Is it the same kinds of things that you mentioned? So the machine learning foundational subjects that we've talked about, the deep learning library frameworks, or is there anything in particular that if somebody's thinking that they're preparing to either be a more advanced data scientist or they just like to be looking to the future, is there anything that you think they should be focusing on?
For entry-level jobs, I would say whatever I've mentioned should cover it. If you are just seeking a junior position, but if you are trying to go into senior level positions for data science, or even as say a senior research scientist, or even a research scientist for that matter, then I would say you need to delve a bit more into the current state of the art and know exactly. Suppose if you're applying for a position in computer vision, you should know a lot about computer vision, because the round 2 of the interview would be strictly based on computer vision, and they are going to give you a research-based problem that the company is working on, and they see what kind of solutions do you have to offer. It might not be the perfect solution, but they see whether you can try and how well do you think about breaking down the problem into nice sub-problems which are easy to handle, and how are you able to attack that problem, and what solutions do you have to offer. So that is what a research scientist position entails in the second round of the interview that I have been subjected to in the past. And I would also say, if there's something specific that I see this trend of ML going towards, it would be unsupervised learning. Because most of these companies, self-supervised for that matter, they still do not have a very perfect demarcation between the two terms, self-supervised and unsupervised. But ultimately, it's like learning from the vast amount of real-world data that we have, be it images, be it just non-annotated data, because the data sets which are annotated, they are very few. And annotating is very expensive and very time consuming. So the big companies might have the resources, the finances to hire people or even outsource it and get those annotations, or even from millions of customers just signing onto their platforms. But generally, startups or mid-level companies, or even academia, the schools, the institutions, they do not have that kind of funding as big companies do. So we try to find out about, ways of finding the inherent pattern in the data that we are supposed to work with, rather than train the model using some ground truth labels. So unsupervised learning is the future. I strongly believe in that. Yeah.
I love it. That's such a great answer, and I agree with you 100%. All right. So you've done a huge amount already in, I think it's fair to say, despite all of your accomplishments, to say you're still in the early part of your career and you have exciting hobbies on the side. Do you have any particular productivity or prioritization or time management secrets that you can share?
Oh, yeah, for sure. I mean, so all my calendars, my work calendars are synced across all my devices. It's very important, because the night before, the next day, I always try to see what I'm supposed to accomplish by the end of the next day, and accordingly, I make a list. So that always helps me to prioritize amongst all the different things that I do. I did not really have this habit, but the moment I started doing research and I started juggling multiple things, I had to maintain lists. So I just pull out my phone or even a piece of paper or on my whiteboard. I just listed down whatever I have to do the next day, the goals I have to achieve. And if there's something really major to be taken care of through in the coming week, I do that on the Sunday. So that I know that it's like a reinforcement signal to my brain that, okay, this has to be done and this much accuracy should be there for this particular task. So that's how I do it. Also, I would say for productivity, this is something I cannot stress enough on. So for research, or even for people who are in data science, in ML, who are studying, right, or even trying to venture into this particular field, I would say sign up for something, for some study sessions or reading sessions online, because that's how I increase my productivity. If I have some ideas that might not work, looks to me fine, perfectly fine, might work, but I always get second, third, fourth opinions from a diverse set of individuals, just to have that extra I would say, supervision on my particular idea that why it shouldn't work. And also like the latest trends, we have like reading groups to keep up to date with the state of the art. It always helps. One person presents and everyone gets to learn from that particular presentation. And then you have the brainstorming session after the presentation. This is very important, I feel, and it increases my productivity a lot. Kind of smart work, I would say.
That sounds brilliant. Those are all such great tips. I do some of those things, and then I've taken some notes on some of the others that I could fill in. So Thank you so much, Deblina. So I know that you're reading a really exciting book right now, and I want to hear more about it. Can you tell me about it, please?
So I started reading Other Minds by Peter Godfrey Smith, and it delves into the consciousness of the octopus, the sea animals, and since how the consciousness has basically developed. What is consciousness? It hits all those hard-hitting questions. And the flow of the way how the author has articulated this entire thing, it doesn't set into boredom, it keeps the grip, it keeps the interest. And I don't want to give away a lot because those will be like spoilers. It really.
Who's the murderer? You don't want to tell us who? Yeah.
No, never.
You don't want to spoil anything.
Yeah. So I do not want to spoil because it's like an experience. If you just take that book, and it's an amazing book. I couldn't stress enough how amazing the book is. Please do read it. I'm really liking reading it, and perhaps with your background, John, you would love it too. Yeah.
Yeah, it sounds really amazing. I got a full PhD scholarship to study consciousness at University College London. So I had to write the proposal and everything, and I was really deep into it. That ended up being not the route that I went down for my PhD. But I absolutely love consciousness, and your book. Yeah, this book sounds incredible. So we will definitely make a link to that in the show notes. And yeah, I'm going to have to make time to read it for sure.
Yeah.
So thank you so much, Deblina. You've had such amazing applications of data science to tell us about. You have had such great practical tips for data scientists, whether they're research scientists or not, and a great book recommendation as well. So how can our listeners contact you or follow you or find you to get some more of your insights in the future?
I'm available both on LinkedIn and on Twitter. So my Twitter handle is Deblina for AI. So we can just brainstorm ideas. If someone wants to follow me, I would be happy to engage in a meaningful conversation. And on LinkedIn too, I think you would post the link. So that would be great if we can chat up. Yeah,
definitely. Yeah, we'll definitely have your LinkedIn and Twitter handles in the show notes. And yeah, amazing. I absolutely loved this episode with you, Deblina. Thank you so much for making the time. And
it was an honor. Thank you.
Yeah, looking forward to catching up with you again soon.
Sure. Thank you so much.
As you could tell, at many points in that episode, I'm so wildly impressed by Deblina's breadth and depth of machine learning know-how, productivity, and clear communication of complex concepts. I had so much fun recording this episode, was inspired, and learned a lot. I hope you did too. We covered so many amazing, cutting-edge machine vision applications, the lifestyle and toolkit of a world-class AI researcher, and the importance in machine learning of a strong foundational understanding of linear algebra, calculus, probability theory, statistics, and data visualization, a cause that's very close to my heart. If you're interested in being involved with some of Deblina's work on yet another diverse project, this one on outer space, Deblina's the head of the sponsoring vertical for the spacecraft team in Lausanne, Switzerland, that aims to send 2 nanosatellites to space by the end of 2023. More than 60 engineers, researchers, and scientists across Switzerland are involved in this project. The data collected from those nanosatellites will be applied to study the upper atmosphere of the Earth to facilitate climate research and to study space debris as well as exoplanets beyond our solar system. Her team has received public funding of 2 million euros already for the project's early phases, but for the next phase of platform development, deployment, and testing, she's seeking private funding of up to 2 million euros. If you're in a position to help out, this would not only provide you with access to innovative technologies, but it would support an extraordinary environmental sustainability project as well. If you want to join forces with her, you can reach out to her directly via Twitter or LinkedIn. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, and URLs to Deblina Bhattacharjee's LinkedIn and Twitter profiles, as well as my own LinkedIn and Twitter profiles at superdatascience.com/439. That's superdatascience.com/439. If you enjoyed this episode, kindly leave a review on your favorite podcasting app or on YouTube, where you can enjoy a high-fidelity video version of today's program. It sure is nice to put smiling faces to all the laughs we had today. I also encourage you to tag me in a post on LinkedIn or Twitter to let me know your thoughts on this episode. I'd love to respond to your thoughts in public. All right. It's been so great. Thank you for listening. Looking forward to enjoying another round of the Super Data Science podcast with you very soon.